Hello students, how are you? Hope you are doing well. Now the question is, if copper wire is stretched to make its radius decrease by 0.1%, then percentage change in its resistance is approximately option A minus 0.4%, option B plus 0.8%, option C 0.4% and option D 0.2%. So the problem is based on the basic formulae, some basic formulae such as R equals to rho L upon A, where A is the cross section area of the wire. Generally, the wire is cylindrical in nature, so the cross section area is in the form of a circle. So we can say that rho L upon pi r square. This is the value of the resistance. Now it is said that the radius decreases by 0.1%. So we can say that the new radius is equal to 0.999 times r, because 0.1% means 0.1 divided by 100, which is 0.001. So if we subtract this from the earlier value of r, so we get this value as 1 minus this thing. So we get this value as 1 minus 0.001, which is nothing but 0.999. So this is the value of the new resistance, new radius. The new radius is 0.999 times r. So this is the value of the radius. Now we can say that one more thing we can say that if the wire is stretched, suppose the wire is stretched, then the volume remains same. Volume is the key parameter here. It remains same when the wire is stretched. So we can say that the length increases. Let L dash be the new length and L is the earlier length. Then the new length multiplied by new cross sectional area, which is nothing but pi r dash square, is equal to L multiplied by pi r square. This is the relation of the volume equality. This is the volume after stretching. This is the volume before stretching the wire. Now this pi cancels with this particular pi, and we can easily see that L dash upon L becomes r upon r dash whole square. This is the value of L dash, and r dash upon r is equal to 0.999, or we can say that r upon r dash is equal to 1 upon 0.999. So in this way we can calculate L dash upon L and r upon r dash. Now the change in resistance, which we have to calculate in terms of percentage, is given by the new resistance minus the earlier resistance divided by the earlier resistance multiplied by 100. So this value comes out to be r dash upon r minus 1 into 100. Now we can calculate the value of r dash upon r. Now r dash upon r, r dash upon r is equal to, this is equal to rho L dash upon pi r dash square divided by rho L upon pi r square. Now this rho, which is resistivity, it cancels. This is same in both the cases. After stretching and before stretching the wire, this remains same. So this rho cancels, this pi cancels, and we get this value as r square upon r dash square multiplied by L dash upon L. Now L dash upon L we have calculated earlier, which is equal to, this is r square upon r dash square. L dash upon L we have calculated as r square upon r dash square. This thing we have calculated earlier. So this comes out to be r to the power 4 upon r dash to the power 4. Now this value we can put here in this particular ratio, r dash upon r. This is r dash upon r. Now this r dash upon r, now this delta r in percentage is equal to r dash upon r, which is nothing but r to the power 4 upon r dash to the power 4 minus 1 into 100. Now this ratio we know that R upon R dash is 1 upon 0.999. So this becomes 1 upon 0.999 to the whole power 4 minus 1 multiplied by 100. Now this value comes out to be 0.4%. So 0.4% is the option number C. So we can see that the option C is correct in this particular case. The change in resistance, percentage change in resistance is approximately 0.4%. So hope you understand the solution. Thank you.